I'm going to do a real quick proof of my force factoring method using divide slide, just showing that it creates a quadratic formula and is completely legitimate no matter what. So if I have a quadratic equation, right, my first rule for forced factoring is that I want to double the equation if my b is odd. Since my b is literally b, I don't know if it's even or odd yet. I'm going to go ahead and double it just to be safe. All right, and now the next step is to find, so my two numbers here, find my factor list and my average. So the two numbers have to multiply to first times last. 2a times 2c is 4ac, and they have to average half of this. They have to add up to 2b, which means that if they two numbers add up to 2b, they average half of that, which is just b. Their distance away from that would be plus or minus the square root of my average squared, which is b squared, minus my factor list number, which happens to be 4ac. Now I have that. Now, thanks to slide divide, I can go straight to my factors, right? Equals 0, whatever, right? Front is x plus my average plus the square root, so that's b plus the square root of b squared minus 4ac, and b minus the square root of b squared minus 4ac, all over whatever I have in front of x squared, which happens to be 2a. And note, there we are. If I was just going to make this factored, I would take that bottom guy and shove him to the front, and shove him to the front after reducing. But since these are equations, I don't have to worry about that, and I'm just going to have x equals the opposite sign of this, of each of these, which would be negative b plus or minus, technically minus or plus, b squared minus 4ac all over 2a, which is the quadratic formula using divide and slide, or I like to call it just the dividing method, or the fractional method, and the force factoring using the average and the square root of the thing squared minus 4ac. Quick side note that's kind of fun that I have found a lot of students liking is the discriminant measures how perfect your squares are. I don't know how many people already know about this whole thing, but let's say I had so, and this kind of like builds off this, the discriminant, right, would be that guy squared, which is 144, minus 4 times a is 4 times c is 9. That is 144 minus 144, which is 0. So a way of looking at the discriminant is that it measures how perfect of a square your quadratic is, right? So, or how far away you are from being a perfect square. So this right here, because the discriminant is 0, that means that is right at a perfect square. And that's only going to really happen if that is a perfect square. So I know this guy goes to, square root of that is 2x, and the square root of that is 3, and they have to add up to negative 12, so that's going to be minus. If I am a perfect square away, that means that it will factor because they'll be off by another rational number. Yeah, and if it's a imperfect square away. You know, like that tells you how far off I am from being a perfect square. I think that's pretty much it. That was my big to do in my class today. All right.